Hi everybody. So today we're going to be working on solving systems of equations where one of the equations is linear and one of the equations is quadratic. If you haven't already done LT 3.1, which is solving linear systems where both of the equations are linear, you need to do that before you do this, okay? So you should go back and there will be a recording on Canvas for solving two linear equations, and you should complete that. If you need the note guide, you can look in the bin that's on the front table that I always keep, and you should be able to look under LT3 and you'll find the note guide for LT 3.1, solving systems of linear equations. Okay, likewise, if you have finished solving linear equations and you have completed the assignment, which you should have done before you do this, you should check your answers on Canvas. That is also available there. The key is there. You should look that over. Make sure that you've got linear systems accomplished and feel confident with them before you go on to this. Okay, so this is a warm-up, and this you should have the note guide for LT 3.2, which is linear and quadratic systems. So you should go ahead and pause this video, complete this warm-up, and then continue. So looking at the warm-up then, I chose to solve this system using substitution. You could use either of the two methods we learned. So if you use a combination or elimination, they're called either one, that would work just as well. I took the second equation here and I divided everything by -4. As long as you divide every term by the same number, we know we end up with an equivalent equation, which would be y equals x plus 1. So I took that little definition for y equals x plus 1. I substituted it into the first equation for y, and then solved for x and got -8. I then took -8 and substituted that back into the second equation. You don't want to use the same equation twice to substitute into. So I substituted it into the second equation and solved and got y is -7, giving me a solution of -8, -7. Now I did check that solution, and you should make sure that you check your solutions too. When you check your solutions, you want to take your x value and substitute it in for x, take the y value and substitute it in for y, and you need to do that in both equations, not just one. Over here in question or problem B, we had a graph given to us, and this is to remind us back when we solved systems by graphing, we solved systems where we had a quadratic and a linear equation, and we learned then that the solution is the intersection points. And in this system, we have two intersection points, so there are two solutions. These are equally important and valid solutions. So the solution on the left is -3, 4, and the solution on the right is 1, 0. And it's because we are looking for these intersection points that we often write our answers to a system as a coordinate pair, as you see I've done down here when I solved analytically. So as we work through today's lesson, which is solving linear and quadratic systems, remember always that we're usually looking for two solutions. It is possible that we could have just one solution. If our line was a line that only intersected at one point on the parabola, then there would only be one solution. And if our line was such that it never intersected with the parabola, we would have no solution. The no solution would end up, we would be working through the solving process and end up with some craziness that where the x's all went away, and we ended up with something like 3 equals 0 or something like that, which of course we know is a lie. You know, you can't have 3 cannot equal 0, and since that's a lie, that tells us there is no solution. So remembering my little life lesson in math, when there's no solution, there is no solution when you lie. Okay, so then moving on. Again, making sure that you've already solved systems of linear equations where they're both linear. You will find that as we work through today's lesson, we're going to use the same two methods that we used for solving linear systems. We just have a little bit more to do because now we have quadratics to solve in there. So we're going to use and have available to us all those quadratic tools that we learned already in this essential standard. We learned how to solve quadratics by square roots, by factoring, by completing the square, and by the quadratic formula. And we can use any of those methods that are convenient for us as we work through this. So our first example here is going to be solving by substitution. So notice what it says over here on the right. Use substitution when the linear equation, and it's important that we see the linear equation, is easily solved for y. So if you look over here at the two equations given, the quadratic equation, equation number 1 up here, is already solved for y. But it's often inconvenient to substitute that in for x. It won't always be so nicely solved for y, or if we do solve the quadratic for y, the expression over here might be, something really ugly, like 1/2 x squared minus 2x plus 9 or something. So, with fractions or decimals in it, we don't want that. So very much easier to use substitution when you can take the linear equation, which is the second one here, where x is to the first power, and solve it for y. So we get y equals negative x, plus 5. And now that I have that, I can substitute that into the quadratic equation for y. So I get negative x plus 5 equals x squared minus 6x plus 9. You're going to have to forgive me. Sometimes my little pen doesn't write real neatly. Okay, so now that we have that, all we're doing is solving a quadratic equation for x. We can use whatever method we choose, but we should start by setting it equal to 0. So I'm going to do that. I'll add x to both sides. Make sure you add x to the x term. And I'll subtract 5 from both sides. And that gives me 0 equals x squared minus 5x plus 4. And using my method of checking for factoring, 1 times 4 is 4, and factors of 4 that would add up to negative 5 would be negative 4 and negative 1. So I can factor this, and since a is 1, this is that really easy factoring that we like. X times x gives us x squared, and then negative 4 and negative 1 are our factors that will give us negative 5x in the middle as our b term, and positive 4 as our c term. So I solve this just like we have before with quadratics. I'll take x minus 4 equals 0, and I get x equals 4, and then that's a 4. It looks like a y, but it's a 4, honest. And then x minus 1 equals 0, and I get that's a 0, x equals 1. Okay, so what we have here are the x values for those two solutions that we're looking for. But remember, when we did this, we said our solutions are like intersection points. That means that they have an x value and a y value. And since they have an x value and a y value, I'm going to move this and get it out of the way here, we have to find the y values that correspond to the x values. So I'm going to take my two solutions that I just found, x equals 4 and x equals 1, and one at a time I'm going to substitute those into either equation. It doesn't really matter which one I use, so maybe it'll be easier if I use the linear equation, which is fine. And so I'm going to take y equals, or y plus, and for x I'll substitute in my first x value, which was 4, equals 5. So y equals 1. So what we just found is that when x equals 4, y equals 1. And then for the second one, we use the same equation, y plus 1 equals 5. So y equals 4. And so now we see that when x is 1, y is 4. So that's a nice little pair of things here, but we want to check. We want to check our solutions by checking into the other equation, just to make sure we didn't make a mistake. So I'm going to take my quadratic now, and I'm going to put in my y value, 1 equals 4 squared, putting x in for x, minus 6 times 4, that's a 4 again, they keep coming out looking like y, sorry, plus 9. 9. Doesn't want to make a 9. You know that's a 9. So 1 equals 16, which is 4 squared, minus 24, and then plus 9. We'll make a 9 this time. So 1 equals, okay, 16 minus 24 is negative 8. And negative 8 plus 9 is 1. So 1 equals 1, checks. All right, now I'm going to check my second solution in the quadratic. Y, which is 4, equals x, which is 1, squared, minus 6 times 1, and then plus 9. So 4 equals 1 minus 6 plus 9. Well, 1 minus 6 is negative 5, and negative 5 plus 9 is 4. So we have 4 equals 4, and again, that checks. So first we solve for x, then we take that and we put it into one of the equations to find our y values. We have an xy pair here and an xy pair here. Remember, you always have to get the x and its corresponding y. And then we checked both of them in the other equation. That's the basic idea of substitution. So now on your note guide, you have a practice problem here to try. So pause the video while you work this problem. Okay, now that you've worked the problem, here is my solution to this problem. I took my linear equation, which is the first equation, x is to the first power, and I solved for y by adding 30 to both sides. I took that expression, 12x plus 30, and substituted it in for y in the second equation. I set the equation equal to 0, giving me 0 equals x squared minus x minus 42. I factored that to be x minus 7 times x plus 6. I set those equal to 0 and got the two solutions, x equals 7 and x equals negative 6. But those don't tell me the intersection points, they just tell me the x values of the intersection points. So I took 7 and substituted it into the linear equation up here. Notice I substituted it into the given equation, not into the one I solved over here, y equals 12x plus 30, but into the original equation, y minus 30 equals 12 times x. And I got y equals 114. And so there's my first intersection point, 7, 114. And then I took x equals negative 6, substituted it into the linear equation, and I got this solution when x is negative 6, y is negative 42. Now I did check that. I'm not showing it here on the screen, but I did check it, and you should check it also to make sure always that you have the right two numbers. It's very easy.